So I agree, but I wanted you using more of that definition. If you look at what I was doing here, um, right? I was saying, what's the value of the function? What's the limit? Do they match? If they don't match, it's not continuous. So, and what you said was, well, here's the function, here's the limit, D and E. You hear the difference between the language.
Yes, can you just help me doing it? Because I'm really like, I think I miss, I'm not really know how to like do it. Can you just maybe
Yeah, what was
please
the function? What was the function? I'll show you what I would have wanted to see. But it was,
let me check it out?
um, I know there was an issue, but,
Yeah, I was number 33, like the
yeah,
function
what was the function?
was x plus,
E to the x?
yeah, a to the x if 0 less or equal to x.
Oh, let me, I have yours here, but I can open it. Oh, yeah. X plus 2, right? For x less than 0. E to the x for 0 less than x less than 2. And 2 minus x for x greater than 1. Of course, we could graph it and see that it's not continuous, right?
You're making a mistake in this second one. Less or equal to 1 equal to
2 minus x is x. Oh, yeah, 1. Yeah, thank you. So something like that, right? So obviously it's not continuous, right? But so at x equals 0, right? We get f of 0 is e to the 0 is 1, right? So step 1, find the value of the function. Step 2, find the limit. The limit as x goes to 0 from the left of x plus 2 is 0 plus 2 is 2, right? So then I would say, since f of 0 does not equal 2, f is not continuous at x equals 0, right? And then what you had was, instead of this, you just had d and e.
Okay. I see.
So I agree that I don't agree that this doesn't exist. I don't agree that this doesn't exist, right? But if I try and say that the limit as x goes to 0 of f of x, that does not exist. But still, I want the continuity piece, right? I agree, the limit as x goes to 0 doesn't exist, right? But
I got it. Thank you, Professor.
nice, good. Well, what do you think? Breakfast time?
Just about.
I'm about to go to bed again.
8 a.m. is crazy early.
Like on Mondays, I get homework turned in at like 4 in the morning. I'm like, oh my God, what are they gonna do? Are they gonna go back to bed?
Yeah. It's not ideal right this minute. Did Nahom still want that question with the squeeze thingy?
I don't know. I'm waiting to hear.
Yeah, I was just waiting for everyone to finish like that.
Yeah, I'm waiting for that one too.
We're ready.
That's it.
We're ready. Do you want to look at the one from today?
Yes, please.
Here
I
it is.
just figure it's free notes, so.
So the way I did it with the identity, correct? Starting at line 1. So Nahum, you were saying something, but I needed you to write it down because I couldn't. What sounded to me of what you were saying sounded wrong. So
Yeah, okay. So, okay, yeah, I get it. No, I was just saying, is sign, look, so you see number 1, the expression on the right sign.
yeah, this guy,
bracket,
right?
Yeah, no, I was just saying, sign, is that expression equal to sine x plus 2x over x multiplied by 1/5? So now,
Oh, yes, sure. So,
yeah, that
that's
was
what I think you're saying now, right? Sine of x plus 2x over 5x, yes, is the same as 1/5 times sine, I'm just factoring downstairs, right? So
yeah,
x
that
plus
was what I was
2x
saying.
all over x, yes.
Yeah,
Yeah, you can see my downstairs is still just 5x, right?
yeah, yeah. Can you go back?
Okay. Now I got it. Like, you get like this like 5 come from, like, that's what I was asking this morning. Now I got it.
Yeah, exactly. But the key is that you know your sine of alpha plus beta, and you know your cos of alpha plus beta, alpha plus or minus beta, right? And so this one is sine alpha cos beta
Yeah,
plus or
Professor,
minus.
can you simplify that part? Because I
No.
just want to see the way.
Oh I'm writing it out. So if I use the plus here, I use the plus here. And this one is cos of alpha, cos of beta, minus plus sine alpha, sine beta. So if I use the plus here, I use the minus here. And those from pre-cal. So those are identities from pre-cal. And it's basically the only way you can simplify this. It's the only way.
So, Professor, the sine, sine 3x is equal to sine x plus 2x. That is okay.
Yeah. So sine of 3x, right? Because that's x plus 2x.
Yes, okay.
That was my question like a long time ago and said that no more squeeze. Yeah, that was my question. If 3x is like is equal to sine x plus 2x, now I understand.
That opens a lot of options to simplify and stuff like that. If you can.
Yeah, it's probably the best way. I should have included that originally when I taught it, but if I did it today, I'm going to put it on the test. Something very similar.
Professor, can you do this part just once? I just want to see how you go through the your thought process when you go through the expression. Can you apply it again today? Yeah.
So I'm going to here now. Okay. So I've got 1/5 times, and I'm using, right? This is x plus 2x, right? So you see, I get sine of x, cos of 2x, plus cos of x, sine of 2x, all over x. And then I'm going to divide and conquer. So divide and conquer, meaning if you've got more than one term in your numerator, you can split them, right? So I'll split them first. I've got 1/5 times sine x cos 2x over x plus cos x sine 2x over x. So divide and conquer. And so now you can see I have a sine x over x. That's what I'm looking for, right? And then I have a sine 2x over x, so I need another identity there. But it's all on that other page, right? Okay?
Exactly. Okay, that's very helpful.
So for the sine 2x, you just use 2 sine x cos x over
Exactly,
x.
exactly. So that becomes a 2 sine x cos x. And then again, I can see that sine x over x again.
Cos 2x and cos x are both 1, so you basically just
All right, breakfast time.
Yes, sir.
All right,
Thank
see you all
you,
Friday.
Professor.
Okay, see you Friday. Good
See
work.
you
guys.
Friday, Professor.
All right. I'll see you then.